Hi everyone, this is Mrs. GA, and today we're going to talk about medians and altitudes of triangles. So a median is a new type of segment for us. It's the segment whose endpoints are the vertices of a triangle and the midpoint of the opposite sides. So let's see if we can draw a median in this triangle ABC. So let's draw the median of angle A. So I'm going to start at angle A. That's going to be one endpoint of my median. And then I'm going to go to the opposite side. So you would measure the length of BC and you would find the exact middle. So I'm just going to estimate. So about here. And then you connect the vertex to the median of to the midpoint of the opposite side. We can show that this is a median by denoting these two congruent parts. Again, a median is not an angle bisector. Just to be clear, we do not know that these two are congruent. A median simply goes from one vertex to the midpoint of the opposite side. So we've been talking about the point of concurrency of different types of segments. So our new point of concurrency is called the centroid. So the centroid is the intersection of three medians of a triangle. So if you look at this picture over here, I know that these are medians because they all go from a vertex to a midpoint. And again, I know X is a midpoint because I see two congruent segments. I know Y is a midpoint because two congruent segments, and the same for point Z. So I know that all three of these are medians, and so that makes this intersection point, point P, the centroid. So the centroid theorem says that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the other side. So for example, AP is 2/3 of AX. So AP, the distance from here to here, from my vertex to the centroid, is 2/3 of this total distance. Okay, we can do the same for any of our medians. So from B to X, the distance from my vertex to the centroid is 2/3 of the distance of the total median. So from B to Y. And Z to X, C to X is 2/3 of the distance of our total median. So we always start at the vertex and go to the centroid, and that's 2/3 of the total median. So let's see if we can use this centroid theorem to help us find the problems in example 1. So we're using this picture over here. So first they say, if AP is 12, how long is AX? So I see that we're working with the distance from our vertex to our centroid. And then we want to know how long is the total median. So let's start with an equation that just has the names of our segments. So we know that AP is going to be 2/3 of our total median, which is AX. So if we substitute what we know that AP is 12. So 12 is going to be 2/3 the length of segment AX. So I'm going to multiply by 3. So we get 36 equals 2 times the length of AX. And then I'm going to divide by 2. So 18 equals the length of our median AX. All right, in part B, they say that CZ is 21. So notice that they tell us the total length of the median, and they want to know CP. So let's start by setting up our equation. So remember, our equation is the distance from the vertex to the centroid, which is CP, is always going to be 2/3 the distance of our total median, which in this case is CZ. CZ. So let's substitute what we know. In this case, we know that CZ is 21. So CP equals 2/3 times 21. So that means that CP is 21. I'll do 21 divided by 3, which is 7, and then I'll multiply by 2. So it's 14. And there you have it. So if you start with an equation from one of our 3 formulas, then you should be able to substitute what you know and find the missing length. All right, so in number 3, here we have a triangle, and we know the 3 coordinates of this triangle. And they ask us to find the coordinates of the centroid. So that means that I'm going to need to draw in at least 2 medians. So let's start by drawing a median from point P. So that means that I'm going to need to find the midpoint of QR. So let's start by finding the midpoint of QR. So remember, our midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So you add up your x values, so 0 plus 6, and you cut it in half, which is 3. Add up your y values, 8 plus 4, cut it in half, which is 6. So 3, 6 is going to be our midpoint, and then we can draw a line from that midpoint to our vertex at P. So this is one of our medians, and again, we can show that by showing that this is 2 congruent parts. And now we need to draw in one more median. So maybe we'll do the midpoint of QP next. So let's find our midpoint of QP. So if I add up my x values, I get 0 plus 3 over 2, which we'll say is just 3 over 2. And then if I add up my y values, it's 8 plus 0 divided by 2, which is 4. So we have 3 halves, 4, which is right here. That's our midpoint. And then we're going to draw the line from our midpoint to our opposite vertex at R. And then we can show that these 2 segments are congruent. So I see that the coordinate where they intersect, our centroid, is at 3, 4. And there you have it. All right, so now we're going to talk about a new type of segment, and that's called an altitude. So an altitude is a perpendicular segment that goes from a vertex to the line containing the opposite side. So every triangle has 3 altitudes, right? One from each angle to the opposite side. And the thing with altitudes is that they can be inside your triangle. So if you look down at triangle ABC below, if I start at A and I draw the best perpendicular line I can see, okay, this is inside the triangle. But they could also be outside the triangle. So if I look at angle B, I'm going to need to draw a perpendicular line to somewhere on segment AC. So first thing I'm going to need to do is actually extend segment AC out like this. Of course, you could use a ruler to get a more accurate line. So you can actually see that the perpendicular line here would look more like this. So this would actually be the altitude. So notice that this altitude from vertex B is outside the triangle, and then this one is inside. And again, it also can be on the triangle as well. Like the altitude could be a leg of the triangle. So the orthocenter is the intersection of the lines that contain the altitudes. So remember, we've been talking about where different types of segments intersect, their point of concurrency. Orthocenter is where the altitudes intersect. So let's see if we can find the orthocenter of the triangle with vertices at the origin, 2, 6, and 8, 0. So I'm going to start by drawing out our triangle. So here's the origin. So that's point A. 2, 6 is right here. So that's point B. And 8, 0 is over here. So that is point C. Now we can draw our triangle A, B, C. Okay, so to make an orthocenter, we need to draw at least 2 altitudes to see where they cross. So let's start with the altitude from angle B, because I noticed that opposite of angle B is a horizontal line. And it's really easy to draw a horizontal line or a perpendicular line to a horizontal. It's just perfectly vertical. So it would look like this. So here's the altitude from angle B. Now let's do the altitude from A. So we want it to be perpendicular to line BC. So if we want a line that's perpendicular to BC, first we need to find the slope of BC. So we can count like the rise over run. I can see that I'm going down 1 over 1, down 1 over 1. So the slope of BC is -1. That means that the perpendicular slope would be +1, which is the opposite reciprocal. So from here, I just need to draw a line that has a slope of 1, and it looks like this. So again, I started at angle A, and I drew a line that had a slope of 1. So I just went up 1 over 1, up 1 over 1. So I can see that these two altitudes intersect right here. So this is the orthocenter. And the orthocenter has a coordinate of 2, 2. Okay, let's try one more together. So let's start by drawing the altitude of angle C, because I can see it's going to go right across here. So again, to draw the altitude of angle C, first we need to know what the slope of the opposite side is. So the slope of AB is 1 over 1, which is 1. Okay, that means that the perpendicular slope would be the opposite reciprocal, which is -1. So I'm going to start at point C, and I'm going to draw a line that has a slope of -1. So I can kind of go backwards in this direction like this, but I can also go straight on through all the way through to continue that slope of -1. So there's my altitude from angle C. Now let's try to find the altitude of angle A. So I'm going to try to draw a perpendicular line to the opposite side, which is BC. So BC is a vertical line, so I know that my altitude is going to be a horizontal line. So you can see that it's going to be going in this direction. So I actually need to extend this side length like this. And now I can start at A, and I can draw my altitude. Again, see, this is making a 90-degree angle with the extension of this line. So remember, your altitude does not need to be within your triangle. It can actually be outside of your triangle. And then I can look at where these two lines intersect, and I see that I have an orthocenter right here. And the coordinate of that orthocenter is 9, -1. Okay, that is all for today's video. Thank you so much for watching.